Hey friends, I'm back. We're going to talk about triple integrals, finding volume. So if you remember when we were dealing with double integrals over a region R, if we just said, calculated with no integrand dy dx, that gave us area. So with triple integrals over some solid D, dz, dy, dx. So for this example, we're going to find the volume of a wedge cut from this cylinder. X squared plus y squared equals 1. So that's a circle of radius 1 in the xy plane, and it's extending up and down around the z-axis. And then we also have the plane z equals negative y and z equals 0. So let's think about what this region or solid looks like that we want to find the volume of. So we've got x and y, and then z is going up. So as we said, x squared plus y squared equals 1. That is a circle of radius 1. So this circle is representative of a cylinder that's going up and down around the z-axis. Z equals 0, that plane just keeps us in the top half of this 3 space. And then what does the plane z equals negative y look like? So that would be a line, a 45-degree line going down in that xy plane, right? So essentially we have like a plane here that's slicing through this cylinder, if you will. So what this wedge looks like is this wedge. Okay, so we've got this wedge shape here, and we're trying to find the volume of this wedge. And it's always helpful for us to picture this because that's going to help us set up our bounds for integration. Now, one thing we should notice or recognize is that this is symmetric here, so we can cut it in half if we want and double the integral value. So let's think about this. We've got our volume. We're going to have some x bounds, some y bounds, some z bounds, and then we'll have, give myself a little more space just for my bounds, dz, dy, dx. Right, so what are my z's going to be in terms of? What's my bottom z? My bottom z is this plane, z equals 0. So z equals 0 up to this max here, and that curve that's creating my top is variable. And it's formed by my other slice, that slice of that plane. So that is the slice formed by z equals negative y. So the slice is what made that diagonal part of the wedge there. All right, what are my y values? Y is defined by this circle. The circle, x squared plus y squared equals 1. And it's really only the left half of that circle. So if we were to take x squared plus y squared equals 1 and isolate y, we would get y equals plus or minus the square root of 1 minus x squared. Now, plus or minus gives us the whole circle. We only need the left half of the circle, so we're going to stick with the minus. So my y values are going from the left half of that circle to, we have this line here, y equals 0. So we've got y equals negative square root of 1 minus x squared, and then y equals 0. And that got a little crowded, so I paused and rewrote it. But we are traveling from least to greatest along the y-axis. The first thing we hit is that left half of the circle formed by the negative part of the square root function. And then the next y equals we hit is this line y equals 0. And then my x bounds, my x's here are going from -1 and +1. So that is our setup. And so, keeping in mind something I mentioned earlier in this video, I said we could slice this here in the middle, and we could just talk about 0 to 1. And if I do that, 0 to 1 for my x, that would be just doubling this. So essentially all that would do would be slicing this here right down the middle and giving us half of that curved wedge. All right, so now let's evaluate the integral. So first thing we will get, we've got 2, the integral from 0 to 1, the integral from negative square root of 1 minus x squared to 0, and there is no integrand, so integrating with respect to z gives us z, which we need to evaluate from z equals -y to z equals 0, dy dx. So I have 2, the integral from 0 to 1, the integral from 0 to negative square root of 1 minus x squared, and my integrand is -y minus 0, which of course we don't need to write. So I've got dy dx. Now integrating -y with respect to y, we get -y squared over 2. Plug in 0, that zeroes out, minus this value squared, so that'll be a positive when I square it, negate it, divide by 2. So what that looks like here, again, we plug in 0, minus this second integral, so that's going to be a plus, and squaring this negative, the square root will cancel, that will become positive. So I have 2, 0 to 1, got 1/2 1 minus x squared dx. And of course that 2 and the 1/2 cancel. So the integral from 0 to 1 of 1 minus x squared dx, which is x minus 1/3 x cubed, evaluated from 1 to 0, which gives me 1 minus 1/3, or my final answer for the volume of this wedge is 2/3. So that is using a triple integral to find volume.